like to move around, so I won't use a mic, but if I need to, somebody will let me know. So I couldn't resist before actually starting the subject matter to just show you a picture from today and a picture from 2017. You may stop and say, wait a minute, how am I going to show you a picture from 2017? So I have to admit, it's an artist's rendering of 2017. So this is looking from the Queensboro Bridge this morning. We have a camera mounted there that looks at the Roosevelt Island site where we're currently building the Cornell Tech campus. And
southward.
And this is looking southward from the bridge. So the tennis bubble's sort of there for those of you who know where the tennis bubble is. And we've started construction now on the first academic building, which is going here, and on a bunch of the infrastructure, and we'll start construction of 2 more buildings in May. And we'll be moving in the summer of 2017. Almost all of the old Goldwater Hospital is missing. There's one piece left, and when that comes down, you'll be able to see from the bridge all the way to the south end of the island, and that'll probably come down.
And that building at the end, that whole long building is coming down?
That's coming down still. And we've ripped down about 8 buildings that size, because the way the site was, it had a whole set of these things in parallel to each other. So there was 850,000 square feet of this old hospital built, and it was a WPA project, so built in the 30s.
Are there still patients in there?
No. They left before Mike Bloomberg left office, so he succeeded in getting, because they had to build a whole new hospital, which is a much better facility than this, and get all the
And
patients.
when did the Jacobs make that grant to get it?
So the Jacobs made a grant to the Jacobs Institute, which is a piece of the overall campus, and they made that about 18 months ago, maybe.
I didn't know.
Yeah,
That was very nice.
so it was great. And so Joan and Irwin Jacobs, Irwin was the founder and ran Qualcomm for many years, gave a grant jointly to Cornell and Technion to build a joint institute that's a key part of the campus overall, and now named after the Jacobses. So yeah, that's why home of the Jacobs Institute, which is the sort of interdisciplinary core of what we're doing.
So is that the way Cornell Tech is supposed to be now labeled?
Yep.
Home of the Jones and Irwin Jacobs Tech?
Yep.
Okay.
Because the institute is sort of a key piece that's a collaboration between the 2 universities.
What's Technion?
Pardon?
Technion.
Oh, so Technion is the Israeli Institute of Technology. I think, analogy is the simplest. They're the MIT of Israel. Which might make some of the other engineering schools in Israel annoyed, but they really are the MIT of Israel. So,
But Cornell Tech is somehow
it's the umbrella.
an umbrella?
Yeah.
And there
So
are other parts of it.
there are. Yeah. So our business. So there's Johnson School, which is Cornell's business school. There's our engineering school.
They have portions.
They have portions of what we're doing on the campus. That's right.
But they're not part of the name.
They're not part of the name, but they're part of the operations.
Was that a
of the
tough
building.
negotiation?
Well, so we just use, so we say Johnson Cornell Tech, so Johnson's our business school when we refer to students in our MBA. So we have about 40 MBA students on the campus right now. We just call them Johnson Cornell Tech students.
Wasn't there an Australian person who made a major contribution?
Well, actually, there's actually Irish American,
Okay.
Chuck Feeney.
Oh, yeah.
So, us academics all like to, think about our own personal brilliance, right? But what really, that was in this competition that the city held, I think what really made the Cornell team stick out was when we were talking to the city and we said, we estimate it's about $1 billion to get the first phase of this campus done, and Chuck Feeney's committed $350 million if we meet.
He was the first.
He was the first. That was Chuck Feeney and Atlantic Philanthropies.
Yeah, that must have been the largest gift you got.
That was by far, it's one of the largest gifts any university's ever got.
Yeah.
I guess he doesn't own a house, or he doesn't own he's very.
The thing about, so Chuck has this I've gotten to know him pretty well in the last few years, and right now his health's a little bit iffy, but Chuck has this philosophy he calls giving while living. He would like to die broke. That's his goal. And of course, there's some timing issues with dying broke.
Without his name on there.
Yep, there's no naming. He didn't want, Chuck has given away about $7 billion and his name is on nothing. So next time you're in San Francisco, if you look at that whole UCSF development there in South of Market, Mission Bay area, the Children's Hospital and the first one of the buildings that went in there. So it's the Benioff Children's Hospital, but I think Chuck put more money into that building than Mark Benioff did. And so he's the sort of silent benefactor of a lot of really interesting projects around the world. And so I try to talk him up, even though he doesn't want to be talked up. So I'm glad somebody asked about that, because Chuck is an amazing guy. So, and then this is 2017. It's looking the other way, because I didn't have a view rendering from. So this is, the first view was from the bridge. This is looking toward the bridge. This is the first academic building, which is about 150,000 square feet. And this building is being designed to be net zero, so that we will generate as much energy on site as is used in the building in a given year. That's an incredibly insane goal, but it's not more insane than the rest of what we're trying to do, building a new university campus in the middle of New York City. Nobody's built a net zero building of any noticeable scale in a climate like the northeastern United States. And a big piece of making that work is demand management, not just generation. And so one of the things we're doing in this building is all the building management systems, all of the data in those systems will be available real time to our students. And one of the goals is to get the students doing projects that make the residents of the building and occupants aware of what they're doing to the energy demands of the building.
And
So
it's
gonna be-
solar generation?
so there's a bunch of solar panels, and then there's also geothermal.
Oh, there's geothermal?
Yeah, so they're both.
Ah.
And some of the solar is coming from some of the other buildings. And then this second building is what we're calling the corporate building for companies to co-locate on the campus. So there's a couple 100,000 square feet for companies to have R&D facilities there. That's actually being developed with a commercial developer. So Forest City Ratner is actually building that and capitalizing it. So Cornell's making a contribution, but we're not paying for that building. And then the residential building's 26 stories. It's about 300 apartments, mainly for graduate students and faculty apartments on the top few floors. And we're doing that in collaboration with Hudson and related companies. So again, they're capitalizing those buildings. So all three of these will open in the summer of 17. And this fourth building, which is an executive education center, possibly with a hotel component, will probably open about 2 years later. We're still working on that.
Given the lack of volcanic activity, use the temperature differential between the water and the air, or what?
So actually, it turns out with geothermal, you can do a lot just given the temperature differential between various depths down below ground versus the air. It's a rock, but if we drill, we get down. Yes, so the Roosevelt Island wouldn't be there if it wasn't a big hunk of granite. It would have washed down the East River with everything else. But it's a big hunk of granite, but when you get below it, we've already done a bunch of test bores for the.
Yeah, it's having a constant temperature that.
That's right.
that does it.
That's right, yeah.
You say you're building a hotel, but is there anything there for the community to utilize that you're sharing with?
Yeah, so I mean, two of the things that we did that are oriented toward the community on the physical campus, then there's a bunch of programmatic stuff that we're doing.
I'm sorry, I didn't hear.
So there are two things about the physical campus, but then there's also a lot of program. But on the physical campus, one is that it's an open campus.
Mhm.
So notice there are no fences and walls around this.
So there's a lot of greenery and stuff.
A lot of greenery. We're committed to a high amount of greenery. This is permanent open space that's about the size of Bryant Park, just to give you a sense of scale, just this
Oh,
year.
okay.
So we're committed to it being an open campus.
Mhm.
And then the other thing is that for community groups, the Executive Education Center, those will be spaces that community groups can have access to, and also to facilities in the building
Public
after
programs.
hours, right? I mean, obviously the classes have to take preference, but for
But
community
you'll
groups.
have like public programs.
And then we'll have public programs.
Like NYU, like other universities.
Yep.
Okay.
Yep. But then we have a big public outreach commitment that we've made with the New York City Public Schools.
Oh, that's good. They
And
need that.
that's a separate programmatic commitment, that's not Roosevelt Island specific. Because there's real city money here, right? This land was given to us, well, leased to us for 99 years for $1 a year, so essentially given.
Oh, then you definitely should share.
So, we feel like we have a commitment to the community. All right, so now let me switch from, I just wanted to, I'm so excited about the campus, I can't. And we are up and running today in Google's building. We have about 100 students now, graduate students. So I wanted to talk today about social systems, and it's good that people are already asking lots of questions, because it would be a lot more fun if people just stop and ask questions along the way. And I think for most people, when you think about digital social systems, things like Facebook and Twitter certainly come to mind right away, these online social networks. And for those of you who have teenagers in your life, things like Yik Yak and Snapchat and Kik definitely come to mind as sort of social kinds of systems online. Instagram, Tumblr, Pinterest, Vine. But there are a lot of other online sort of ecosystems that are arising that really are social systems. So Kickstarter's one of those, right, which is a place for people to raise money for things. Any of these things like Amazon and IMDb, where there are a lot of user reviews online, these are really communities where there are respected individuals who are parts of that community. Waze, which maybe is a little less visible in the US because it's an Israeli company for navigation, but it's now at the core of what Google Maps does to give you directions around. It's sourcing from all of its users what the traffic is. So whether you know you're part of a social community or not, you are. When you're using the system, it's getting data about how fast you're moving to share that collectively and improve the experience for people. Uber is building, and I actually left off Airbnb, which is another one of these. These are building very different kinds of social systems, and if in some parts of the world, the regulators are reacting strongly and saying this disrupts our taxi market, so you can't operate Uber. In other areas of the world, Uber's really changing the ways that people engage with each other in certain forms of commerce and in certain forms of transportation. So these are all systems that I would argue are digitally enabled and facilitated social systems. Some of them are economic social systems. Some of them are social systems that don't have sort of explicit economics around them. And all of them, I would say, affect people's daily lives in major ways. So this is something that I think is much broader as an area than what you might think of when you immediately sort of think online social networks of the sort of Facebook and Twitter variety. And just as by way of context here, I think when we think about this broad set of online social systems, I think that one of my sort of deep questions, concerns, whatever is the sort of Aldous Huxley Brave New World concern. And I think as a society, it's been a lot easier for us to worry about Orwellian downsides in the world because there's the evil dictator or the evil government, and it's spying on all of us. And so I'm not saying that we're necessarily, as this either national or global society, doing everything that we can to sort of push back on Orwellian dystopias, but they're very visible to people, and from everything from sort of what the NSA does to other things. But I think Huxley's dystopia is much less visible. It's the dystopia of the truth being drowned in a sea of irrelevance. There's just so much chatter out there that nobody really even has the energy to pay attention anymore to what's really true or not, what's really the basis of scientific or other kinds of investigation, and what's sort of completely unsubstantiated opinion. And as we drown in more and more information, this should ring true for some of what's happening today. And I think another sort of Brave New World Huxley kind of dystopian fear is what you might summarize as this sort of tyranny of distraction and of sort of egocentricity, that you get focused on the self, immediate gratification, entertainment, constantly being distracted by all the things that are going on around you, and don't have the time to, say, be an engaged, productive citizen working on the deeper issues of society and the world. And so, I think that, and by the way, I'm an optimist about technology, so I don't mean to say that this is where I think we are going or must go, but I think in the same ways that we as a society, to be responsible, worry about the Orwellian consequences of technology and development. We should be giving equal weight to the sort of you know, Huxley Brave New World kind of dystopias, and I think we don't. And so kind of the underlying theme of what I wanted to talk about and sort of have as the basis for our conversation this afternoon is that sort of concern in light of this huge increase in the amount and availability of information, the degree to which it sort of bombards us all the time, the degree to which completely new means of social, both information dissemination, but also means of social interaction and even sort of economic things like Uber and the taxi market, the rate at which these are occurring is growing rapidly. And if we don't have sort of the scientific basis and understanding of these changes, I think the risks of these kinds of outcomes, negative outcomes, go way up. And I think we don't have enough scientific basis here. Yes, Scott?
There's a strategic overlay to this, that all these things are also new fountains of possibilities for strategic manipulation, including by multiple actors.
Absolutely, absolutely. I mean, and you know, and I think if even just to pick something in the press recently about Uber, just not to pick on any specific company, but just because it's been in the press quite a bit, where there were some allegations that Uber was using information about where reporters who were not necessarily positive about Uber, where they were going, sort of sort of spying on people, and you can imagine manipulating people, right? It's not a big step between sort of monitoring somebody you don't agree with and making sure their cars take longer to get there, or so I mean, I think that and it it sounds silly at the beginning, but if you think about our daily lives, these things can, I mean, if it's an urgent situation, these things can literally.
And low visibility manipulations, not just manipulations.
That's right.
But,
They can be very.
The other guy's cars take 5% longer to get there.
Yep. So I mean, I think all of these systems are very subject to this kind of thing, and I think a lot of the questions around the design of these systems, what our understanding is, how you might have the tools to detect when these systems are being used in ways that society broadly might not view as playing fair or having a level playing field. These are all questions that I think are fundamentally questions for scientific investigation and analysis, and broadly across the sciences and policy. So I'm a computer scientist, and I bring a particular lens to these things. But I think that the set of policy issues, the set of social science questions, the set of legal questions, these are all as important as the technology questions. But that makes me even a little more worried, because if there's one thing as academics we're not so good at, it's bringing really disparate disciplines together to solve hard problems. We're better at solving hard problems that fit squarely into disciplines, or maybe a pair of disciplines kind of collaborating on something. So as I said, I'm an optimist, and I can sound a little like a pessimist here, but it's more that I'm trying to build awareness for something that I think is important, rather than I'm pessimistic about the outcomes. Yeah.
Is it fair to say that the distinction you draw between Orwellian and Huxleyan could be summarized by saying, in the Orwellian threat, there's a visible villain, and in the Huxleyan, we kind of have nobody to blame but ourselves?
But ourselves, yeah, we're the villain. For sort of not investing enough as a society in really getting a grip on what's going on around us. And as change accelerates, I think it's inherent that the risk of that goes up, because it's hard to pay attention when everything's going faster and faster and faster. So, yeah, but that's a very good summary. Thanks.
I wonder if you haven't suggested the problem that most people have of sort of rejecting things that don't match what they believe in, and accepting maybe too readily things that they believe in. And with the massive increases in information, that makes it very easy to just get reinforcement.
Absolutely. Yeah, absolutely.
And that seems to me to be even more serious.
It's definitely another piece. It just, I was sort of painting the Huxley vision, and he didn't, at least to my reading of Huxley, and if there's a Huxley scholar in the room, they could, but I would say these are sort of his main themes, and I think that there are a lot of things also that are driving the sort of narrowing of people's interests that aren't purely these social systems, and so I wanted to sort of today maybe focus on these online social systems. I think even just the way media works today, which is often not social, is reinforced. And Fox News alone versus CNN, they're starting to narrowcast. There used to be 3 newscasts that everybody watched on ABC, NBC, and CBS. So I think there are a lot of things reinforcing. So I think it's a really important trend, but not one that's sort of dominated by or specific to some of these new online social systems. They play there, but they're not. It's not primary, I would say, but it's a very important.
There's another dimension to the Brave New World, which is it's a biological dystopia in a way that 1984 is only marginally so. And one thing which is missing here, although not inconsistent with any of this, is what happens when social information starts to expand to include a lot of biomedical information, with the ultimate being something like chip implants, increasing human memory, then possibly interconnected networks, on a 30-year horizon, that sort of thing is, I think, only going to get more important, and so the biological dimension here is crucial.
Yeah, I agree.
Maybe we should move along.
Yeah, and
More
so
than 3 slides.
I do, and I'll speed up. So anyway, this is supposed to be the background, and it's good because it got people engaged studying online social systems. So I think the obvious piece is this sort of opportunity to do social science research at scale. And my colleague John Kleinberg, who some of you know, and who much of the work I'll talk about today has involved John in one way or another, often refers to this as sort of behavioral microscope or telescope. It's kind of the analogy for the social sciences to when we started being able to see things in the sky for astronomy or see things that were small in biology. But I think this other piece is getting a better understanding of these new social systems and their consequences, both intended and unintended. And the fact that as a society, there's relatively little research on these kinds of problems today. Especially this cross-disciplinary work that brings a lot of disciplines together, and the federal government's not doing a good job of funding this that well either. There's another sort of more pernicious piece, I think, which is that while the societal consequences here are huge, in some ways people almost resist developing a better understanding of these online social systems because of kind of fear of social engineering. And yet that social engineering is happening. Companies are doing this all the time. If scientists aren't, we're not even building the models for society to really get a better grip of what's going on. And I think peer review, often you'll get back these reviews from NSF or other agencies that say, well, this is just too creepy to work on, but it's happening. So it's not, the creepy is not. And just again, as an example of intended and unintended consequences, I think, with social media, if you Mark Zuckerberg would be the first person to say that, and or any of the Twitter founders, that it was designed to democratize information, to have sort of the Arab Spring or the Hong Kong umbrella revolution. Those were things that they were hoping for. But lately, this is probably what it's facilitating most, which is ISIS. And then on the social network side of connecting people, sharing. And which is very important. As humans, we're hardwired to share lots of stuff, and then from the advertising component. But there's again, and I view targeted advertising actually as a plus, not a minus. But there are a lot of negative sides to those, and so just developing better models and understanding of these systems, both mathematically, computationally, and in terms of the social sciences and policy. And then on the worrisome science side, I think. Companies have most of this data, and they're doing it anyway, regardless of whether academics are engaged in things in a sort of open, public, scientific conversation. Controlled experiments are even harder to perform when most of the data is not something and systems are not things that universities can engage in. But this is a place where, again, this sort of fear and lack of understanding actually exacerbates the lack of research. And as an example, a colleague of mine in Ithaca was involved in a Facebook mood study, which you may have seen in the news about 6 months ago. Jeff Hancock, who's in our information science and communications departments, where they manipulated the news feed on Facebook to include either more positive or more negative words by rearranging the stories in people's news feeds, or left them alone. So they basically had the positive condition, the negative condition, and the control condition. And they saw some very small effects on the tonality of people's resulting posts. So there was a correlation. Not, didn't account for a lot of the variance, but there was a correlation there. But there was a lot of negative press around manipulating people's moods, which is both understandable on the one hand, but companies are doing this kind of A/B testing all the time. They're very concerned with manipulating your mood but they're doing it all for ad dollars. And so again, I think if we're going to hold the kind of public investigation of these things to some higher standard than what's happening behind closed doors, that's a risky situation for society. I don't know how to answer this, but it's sort of the backdrop for all of this kind of work. So that's the philosophy. I'm done with philosophy. I'm going to put my computer scientist hat on. But I think the philosophical background is important. So I wanted to talk about a set of different systems that we've analyzed over the last really 10 years now. And they're all social, but they may not appear social on the front of it. And I'll just run out of time and we'll stop, because I've got a list of way too many such systems. So the first one I want to talk about is Flickr, which is an online photo sharing site. And people share billions and billions of photos. In fact, the last count on Facebook that I knew of was 4 billion photos a day, and that was a long time ago. So people share a lot of photos. What's interesting about Flickr is they tend to be pretty high quality photos that people have really, the Facebook photos tend to be whatever random thing is going on in your life at the moment. And all of these photo streams have geo and temporal information, increasingly geo and almost always temporal. So they're tagged with location when it's available, which is when it's your phone, it's out there, it's always available, and even a lot of cameras today have geo data and timestamps. And this lets us detect both interesting patterns of aggregate human behavior, but also potentially reveal things about individuals that they had no idea that they were revealing. So clearly if you're posting photos with your name attached, you're revealing things about where you've gone and other things like that you expect to. But you're also revealing things about who you know with very high probability. About who you know with very high probability. And those are things that don't necessarily come to mind immediately when you post a photo. So the first set of things I wanted to show you is sort of, I think, the fun side of this aggregate photo data. It's not modeling and understanding these systems explicitly, but it's showing some of the latent kinds of information that's in these social systems that was really not intended by the designers in any way. There's a very simple hill climbing technique that works well for low dimensional data. The easiest example is just points in a plane. So you take a disk of a fixed size, plop it down, compute the center of mass of the points that lie inside that disk, the centroid, and now shift the disk to the centroid. So you're going to tend, that disk is going to, if you've got a bunch of points drawn in the plane, that disk is going to tend to climb up to places that are high density, that have a lot of points. Because you're shifting it, inside the disk, you're moving it to where there are more points in the disk. So you're going to tend to have that thing climb up to these higher density places. So if we now just think of the latitude, longitudes where photos were taken, just think of them as points in a plane. I realize the globe is not a plane, but just think of lat longs as XY coordinates. You can think of plopping disks down and going along and doing this mean shift technique to find the place where there are a lot of points. Those are the places where people took a lot of photographs. And the size of the disk is a natural sort of spatial scale. So you might say, at the scale of a city block, the sort of scale of a landmark, where are the peaks? Or you might say at the scale of a city, where are the peaks? So at the scale of a landmark, you might draw something that's maybe 50 meters. At the scale of a city, it might be 5 kilometers. And so you can find cities, neighborhoods, landmarks, just by simple clustering of this two-dimensional data. So this is generated from Flickr data, and people tend to tag their photographs. So when we find these peaks, we can also find the most popular tags on the peaks. So this column is just looking at Earth, and at the scale of a few kilometers, the scale of a city, just finding the biggest peaks and the most popular tags on each peak. So you find New York, London, San Francisco, Paris, Los Angeles, Chicago, etc. So just sort of the aggregate data identifies major places that people live and take photographs. And now if you make these little disks that you cluster over the size of, say, a city block, you find peaks that are at that scale, and you can do that across the whole globe, or you can do it in the kind of region that you found for each city. Doesn't. And so we found the major cities, and we've also found the top landmarks. And one of my favorite things about New York is that the 5th landmark at the time that we did this was the Apple Store. And you all know which Apple Store, right? I mean, there are now a lot of Apple stores in New York. At that point, there was only the one up by the South End of Central Park.
It's the Fifth Avenue one.
Yeah, 59th and 5th. So a lot of people photograph the Apple Store. So the notion of landmark here is generated completely from behavior. And because a lot of photos are of traditional landmarks, a lot of things like the Empire State Building, the Eiffel Tower show up, but so do a lot of other things. So this is just sort of a visualization of this, where this shows a dot for every Flickr photo taken in North America at the time we did this study, which was about 6 years ago now. There are interesting things just, again, about human behavior, like the coasts. People take a lot of photos near the coasts. The road networks. So just static photos show actually a fair amount about human behavior and activity when you aggregate them across large numbers of people. So the broader message here, I think, is not just about what we can get out of Flickr data, but it's about what powerful latent things there are about human behavior in very simple attributes of this kind of social data when you aggregate over large numbers of people. This is a pretty darn good map of the United States. The interstates are showing up. Everything else is just dots. And then these are the clusters at the city scale and the landmark scale. So you get like Seattle and the Space Needle. You get Boston and Fenway Park as the most photographed thing on Flickr in Boston. And so it's almost sort of an automatically generated travel guide from human behavior.
How many people took photos?
So this data set is from hundreds of millions of photos, and those hundreds of millions of photos were uploaded by millions of people.
Millions of people? How many millions?
So this particular data set, I'd have to go back and look in the paper.
How many
it's
people don't do it?
Oh, I mean, today, and this study's from, about 6 to 8 years ago. So,
8 years ago, how many people didn't do it?
So,
Didn't do anything.
yeah, so I mean, at that point, the fraction of society that did this was
That's
very
my
small.
question. Yes.
It
But
still
to-
is. There's still more people off social media than on.
Yeah, but Facebook's got about 1.2 billion or so relatively active users. It's a big percentage of the world population, and especially in developed countries where the
But
bulk
there's
of their
still
users
more
are.
people off
Yeah,
now.
yeah.
How does Instagram fare with Flickr?
Pardon?
How does Instagram fare with Flickr?
Oh, there are way more images uploaded to Instagram.
Yeah, that's what I'm
yeah,
thinking. Yeah.
much more. So they're literally.
So why did you choose Flickr over Instagram?
Oh, because we did this study before there was an Instagram.
Oh.
So when we did this study, the pace at which this stuff is changing, Instagram didn't actually exist when we did this study.
How did you get permission to get all this picture?
So these pictures are all ones that people posted for public viewing. And so we mine the data.
And how you isolated the landscape pictures from personal pictures?
We did. We just
There are
clustered.
people there also?
Yep, but what's interesting about Flickr is that the sort of canonical pictures of places usually don't have people in them. If you did this on Facebook, they'd all have, right? So people use these media differently.
Yeah.
And so on Facebook, almost all the pictures, there's a person obscuring the landmark. But on Flickr, people are, they want to share, they're more sort of documentary about the place rather than about the people. And so that's a piece of why we would choose it even today in doing this kind of a study. But the broader picture is just that there's a huge amount of data available latent in this kind of social data source that can be used for very different purposes than anybody intended.
Great terrorist targeting advisory.
It is. It's tremendous. I mean, there are, these information sources are of great value to almost anybody who wants to do evil in the world.
It tells you what landmarks to destroy.
It also, even if you look more, it'll tell you what time of day people are there. It will tell you will learn a lot of things. You could pick the hour in the day that you would kill the most people in a landmark, if that was your goal.
So this isn't like an outline of the United States. This is just the dots.
Just
Pure
the dots. There's nothing there but dots. 1 dot per photo, which is, and all of that structure you're just making up with your eyes.
But is it high correlation with the population?
I can promise you that this part of this interstate in the middle of what's probably Nebraska there, no. It's correlated with, like this really shocked the heck out of me when we saw it. Why are people taking photos on interstates that they think are interesting enough to upload to a place like Flickr, right? This is not, but they are enough for these things to show up. So there's a lot of, so I think another thing that's really interesting about these kinds of data sets is they show a lot about human behavior that's not evident. Like if I asked anyone here beforehand, I think most people would say, Flickr photos? No, you're not going to see the road network in the United States. But you do. Yeah.
Over what time period? Like how long? Was it like for 1 hour? Or?
No, so this was all photos taken in North America over about a 3-year time period. So this was a gigantic chunk of photos.
But how many people took these photos? Not everybody took.
No, but 10, 20 million.
Anybody
Yeah,
took
but-
photos with 10 up.
Yeah, but 10 or 20 million people, it's a lot of people. Way more people than anybody would ever poll in any kind of, say, polling, which is usually thousands of people. This is tens of millions of people.
But it's not a representative sample.
But it's not intended to be. I'm not making any claim about, the representative nature of this. And I think, this is another place where, to just dive more about sort of scientific philosophy for a minute, I think that in a world where data is rare, random sampling is incredibly important. In a world where data is ubiquitous, random sampling is a trap. Because the issue is that, and I'm not saying that you should make claims about data that's not randomly sampled that you could only justify from random sampling. No, I just said it's amazing that these structures that we know exist, I've been on that highway, I know it exists, that they show up in this data. I'm not making claims about this being representative of the average person. In fact, the average person is not driven this stretch of highway, right? This is aggregation across a bunch of individuals, which is a very different take on data than the sort of small sample size.
How can you draw any conclusion?
I think you can draw lots of conclusions from things that aren't. That's why I was saying I think random sampling is a trap. Because I think there are lots of conclusions that you can draw where you're not trying to extrapolate to the full population, right? Random sampling is when you want to extrapolate something to the full population. I'm not trying to extrapolate to the full population. I'm saying that in aggregate, there are a set of behaviors that are exhibited in this data that are interesting by virtue of the scale of the data.
Well, I'm a photographer, and I have never done Flickr or Instagram. However, I know quite acclaimed photographers who, and also contests, galleries, museums, magazines, who, if you want to deal with them, will say upload it on Flickr, and if you don't, you won't be entered in this contest or
So
be
this is
up
the
for
sort
this
of quasi-professional photographer.
exhibition. And Instagram is the same. Did you bother to notice what was fine art, professional photography, or you just
No,
put
we
it
just
all?
took everything on Flickr, and my characterization of Flickr would be what you said. It's the quasi-professional. It's people who are often competing and sharing. It's not the sort of family photo, but it's also not usually the professional that's using something else. It's sort of quasi-professional. So this is just a step through a few others, like Northern Europe. You can do this at the city scale. The data gets sparser, at least in the data set that we had. But again, you see a lot of the Manhattan street grid, and again, a lot of landmarks.
Do you have any correlation with tourists?
So Flickr's not super heavily used by tourists, but you're certainly seeing a number of tourist-related kinds
No,
of.
if I do a map with how many visitors.
Oh, yeah, no, we don't. And one of my former students has actually done a lot of work with this Flickr data, looking at what you can gather from it about environmental kinds of things like snow cover, and there they have other data sources that they actually compare the Flickr data to. Here we haven't done that kind of work, but there are people who are working on using this sort of data and then using other data sources and saying, how much is this data a reliable indicator for that kind of data source? Which again doesn't say that this population says anything about the population at large, but if this population and the photos that they take tell us something about the changes in snow cover over time, and it really becomes another sensor for these kinds of things, that's quite interesting. We use aggregate behavior of people for something very different than what is intended for. So the big point here is that the data can be used in ways that nobody intended, and sometimes that's good, sometimes it's not. This is a point that I think is probably a little more disturbing, which is that, so these are the probability that two people who took photos within either 80 meters or 800 meters of one another on the same day have a social tie on Flickr. So Flickr has a social community also, so people can say that they know each other and comment on each other's photos and so forth, because it's this quasi-professional community. And so if you took just, say, 3 photographs in 3 different places on the same day as somebody else within 80 meters of them, there's a 90-some% chance that you guys had a social tie on Twitter, on Flickr. So you're revealing a lot about who you know just by posting this data. And that, I think, is, those are some of the potential privacy downsides of all of these systems that are really difficult to foresee on the surface. Right? You wouldn't imagine that those probabilities are that high for that small a number of events, but they are. So I think that's sort of an interesting side of these things. So now I wanted to talk about something that's a lot more on the modeling side. So Wikipedia is something that pretty much all of us use, whether we like it or not. But Wikipedia is not just an encyclopedia, it's a really active community of editors. There are about 500,000 people who contribute regularly to Wikipedia, and who have what are called profile pages. So these are active editors who have a user ID on Wikipedia and who converse with each other about the pages that they're editing, and have sort of identifiable personas on the site. And so we've done a set of studies where we've looked at this group of users. So it's not huge, it's 500,000 people, but they're editing, and this is English Wikipedia, but they're editing something that a lot of eyeballs look at. And so, arguably their behavior is of much broader interest potentially than the size of the community. And you can think about each Wikipedia editor as having interests that are reflected in the pages that they edit. So you could, to take it sort of to one level further of abstraction, you could literally think of this huge vector where there's a dimension for each page on Wikipedia, and there's a count for the number of times a given editor has edited that page. So I have a personal vector that's so many millions long because that's how many pages there are on Wikipedia, and it's just the counts of how many times I've edited each page. It's an incredibly sparse vector, almost all the numbers are 0, but you could think of that as a crude indicator of my interests. How often do I feel like this particular page is something that I need to pay attention to actually contributing to? So we have this notion of people's interests, which is just their behavior vector across the set of edit vector
The
across
size
set.
of the edit matters? If you edit only one letter or if you edit...
No, right now we're just counting edits.
Because this is a little bit
We could look at size. We looked at both and didn't see in what we were looking at there being much of a difference.
When you edit a paper, sometimes you get there only to change a word. But
Yeah,
sometimes you change the
yeah.
whole
So we
paragraph.
looked. I mean, we have the data for each edit about how many characters were changed. The vector of number of characters you edited per page and the vector of number of edits per page, at least for what we were looking at, wasn't very different. So this is simpler. But we did look at the edit counts also. There are also social interactions between Wikipedia editors. So we have 2 measures here, one of which is your interests, which is your edits across the space of pages. And then there are all of these discussion forums where these editors interact with each other. And so if people engage in discussion with each other on the discussion forum, that's a social interaction. It's a stylized social interaction, right? It's not just like going to the bar for a beer with somebody. But, and so what we've done in this set of studies on Wikipedia is to look at the interplay between people's interests and their social interactions on this site. And in particular, one of the things that we've looked at is what's sometimes called homophily, or the birds of a feather flock together kind of notion. And there really are 2 processes that underlie homophily, this tendency of people with similar interests to be interacting. One of them is a social influence process, right? We influence the people that we interact with, and so they tend to have a more homogeneous set of interests because we're interacting with them. But on the flip side, there's a selection effect, which is also very powerful, which is people who have common interests, tend to interact with each other by virtue of their common interests. And teasing apart those 2 components of, so homophily is just sort of observing at the end, yep, the people who are in this group have more similar interests within the group than across groups. But did it happen from social influence? Did it happen from selection? How did the combination of those things contribute to that observed state? And that's some of the kind of thing that we can start to pull apart as we build models of behavior looking at these kinds of edit interactions. So in particular, here's a plot of similarity. So we just can have, and you can pick your favorite measure of vector similarity. Again, this doesn't look all that different for different measures. This is a cosine measure of the vectors. So this is looking at pairs of editors on Wikipedia, how similar their interests are, plotted as a function of when they first communicated with one another on Wikipedia. So, and this is, so let's just look at the black curve for a second. This is really active editors who have over 100 edits on Wikipedia. And so the 0 here is where for each pair of editors who communicated with each other on Wikipedia, or in this set of active editors who edited 100 or more pages, for each pair, this is the average similarity at the time that they first interacted. And then we can go backwards in time and look at similarity, and time here is just based on number of edits rather than wall clock time. And we can go forward in time. And the degree to which people are getting more similar to each other before they ever interact, that's indicative of a selection process, right? If you think about people as sort of moving around in some interest space, as their interests get closer and closer together, their probability of interacting goes up. So that's indicative of a selection effect. And then, after people have interacted, there's more of a social influence kind of effect. It's people's behaviors changing because they're interacting with each other. And what's sort of interesting about this data is there's this very steep increase in similarity before people first interact, which sort of suggests that, again, I just sort of think of this as people as particles moving around in this very high dimensional space of possible interests, and they kind of accelerate towards each other, and then smack, they start to communicate. And then that levels off again a lot after they work with each other. Yeah.
Why did you pick groups of two? Like, is that like where most of the action is? Or
Just because the easiest thing to measure was communications between pairs of people, and similarity between pairs. But if you really look at these pages, there are a lot of people on the page, but it's much easier to tell who responded to whom than it is if you sort of just look at everybody who posted something on the communications page.
Well, I feel like sometimes there are groups of editors dealing with a thing.
There are, and we just sort of consider all the pairs. So if there's a group, we're just sort of looking at all the pairs in the group.
Okay.
And then this set of plots is just, they get shorter because they have their shorter edit histories. But there's this similar kind of phenomenon that there's this rapid acceleration up to when they first interact.
How do you measure similarity?
So similarity is just, you've got these two high dimensional vectors of people's interests that are just counts of page edits, and you could use like the cosine of those vectors. There's a lot, there's a bunch of these measures of comparing sparse
And they're
vectors.
roughly the same.
Yeah,
Give roughly the same.
they give pretty much the same answer. Like if I did this is a cosine plot, if I remember right, yeah. But if you use one of a number of other measures, qualitatively, all that would change here is the y-axis. So there weren't extant models that did a reasonable job of predicting this kind of outcome. So there have been models of selection and influence on social graphs. For example, there's a model by Holman Newman that's a sort of physics-motivated model where at each time step you either change your interest to be something that's closer to that of your immediate neighbors. So you sort of flip a coin and you say, am I either going to adjust myself to be more like my neighbors, or am I going to rewire my network to pick somebody who's more like me, get rid of somebody who's not so like me and add somebody who's more like me? And those kinds of models don't predict anything like this kind of an outcome. So we sort of started trying to think about what reasonable models here might be. And we actually went to sort of we went back to sort of classic EARN models, sort of sampling from EARNs, with the very simple twist that these are essentially EARN models on networks. So that you have a set of your own activity history, which you can sample from to do your next action. But also you have neighbors in the network, and so you can pick a neighbor at random and sample with some probability from their set of activities rather than your own set of activities. Or there's a little more complexity in the model. You might sample from some background distribution because, look, there's stuff that just happens in the world that's not predicted by the network. So somehow those kind of broadcast effects we had to account for in the model. And then you might create some new activity that neither you nor any of your neighbors have engaged in the past. So it's still a pretty simple model overall. And the general sort of qualitative shape of that model looks a lot like the kind of process that we see. Now, is it an explanation? Of course not. It's a model. But it's an interesting model in that there aren't models out there other than this that give any sort of indication of this kind of rapid acceleration of similarity that's a selection effect. And then this very, very long sort of ramp of continued increase in similarity over time, which we do see in the Wikipedia added data. So this is, you know, as I sort of said in the more philosophical introduction, I mean, they are both consequences of these kinds of systems that we don't necessarily know and understand very well. And that was sort of the purpose of the Flickr data, was to kind of show one of those concretely. But there are also opportunities with these sorts of models to really try to develop a more fundamental understanding of what might be going on. But, you know, in the traditional social science sense of you don't really know, this isn't really necessarily a predictive model, it's a descriptive model. But at least it's descriptive in ways that match the aggregate behavior, which there hadn't been such models before. Yeah.
Isn't the conceit of Wikipedia, though, that this is sort of just noise, and that even if, say, Tea Partiers get together and take it upon themselves to edit the articles about Iraq and WMD in a certain way and edit similar articles, that the bleeding heart liberals will then come along and gang up and sort of balance it out, and that overall you get the noise you get the signal within the noise. So
right, and so and our measure of interests here is what pages you edit. So the bleeding heart liberal and the right winger, who are both editing the same page from completely different political persuasions, we're going to say have the same interests.
Right.
Because they are both passionate about whatever that topic is and trying to push it towards their viewpoint and away from their political opponent's viewpoint. So here, you know, those are those people who, you know, are interacting and who are shown here. So it's not, our notion of similarity isn't sort of all the left-wing people are similar to each other and all the right-wing people are similar. It's that those left and right-wing people who are both passionate about a topic, like, I don't know, you know, pick your favorite topic in the news these days. Keystone Pipeline, evolution, right?
Control for subject.
So it's a subject matter notion of similarity. Yeah.
But it's a subject matter, but not necessarily who's a Democrat.
No, definitely not. It's only subject matter. So
Because
I can't tell if you're pro or anti-Keystone. I can just tell that you edited a lot, or pro or anti-evolution.
Because it is interesting, the Democrat, because most people, they go on and on about this stuff and they don't realize little facts like Dr. Martin Luther King was a Republican. You know, and they just go on with this, that they're crazy, they're insane, you know, it's really strange.
Yep. That's, yeah.
You had to fix the parameters to get there.
We did. So, you know, there are parameters, and basically what we did is we looked at the data and said, you know, what are reasonable settings of these parameters? But these are pretty coarse parameters. They're not parameters that.
But they weren't fitted.
They were not fitted.
What is
Yeah.
K?
Oh, so again, I just kind of cut a figure out of the paper, but the notation here is this is, we look at your activity history as a vector, right? And so then we have a model of sampling from that activity vector, and that's all that this notation
But
is.
E is the expected value?
Yeah.
And K is?
I'd have to actually go back and look at the notation of the paper to remember. Yeah. But it's an expectation, you know, I mean, this is a probabilistic model, so we have a sampling from the space of possible things based on the weights that are due to your previous behavior or that of others. Yeah.
So since you kind of lump left-wing and right-wing people together in that context, does that mess with your data at all in any way?
No, because all we're really looking for here is this sort of simplistic measure of similarity, which is what you're interested in, but not sort of your viewpoint. Not your viewpoint on that topic. It's just.
So it just matters what subject.
What topics? That's right. Yeah. So with that, I think I'm going to just kind of jump to the end and open up for more general discussion. Since
Give us
one more example.
We distracted you with so many
All
other
right.
stuff.
This one will be quick. So Stack Overflow. So this is a very different kind of social community. It's a question and answer site. This, for any software developer, this is the place you go to get your programming questions answered. So people ask questions, they get answered. And what's very important on these sites is that the participants vote to upvote the important questions and the good answers to the questions. And so one of the things that's very used a lot on this site are badges that reward people for certain kinds of behaviors. So this particular person who answered has 8 gold badges, 48 silver badges, and 71 bronze badges. So this guy's collected a lot of badges. And this leads to sort of an interesting broader question about badges as incentives. A lot of online sites are using badges these days. Badges have a very broad set of, look, this is back to Boy Scout patches and Girl Scout. Badges have a long history, not just in the digital world. Increasingly, people are talking about badging as credentialing and not just as sort of rewards. But badges as incentives, which is how they're used in a lot of these online sites, are not that widely studied. So there's a lot of study of things like auctions and leaderboards and competitive kinds of settings, and both a lot of mathematics underlying those, but also a lot of computational studies. But if you look at, these are not explicitly competitive situations. We could all win a badge. The badge is slightly devalued if everybody gets it trivially, but it's not like an auction where there's a winner and everybody else loses. So they're sort of fairly weakly competitive situations. And so we've investigated a broad set of questions here about whether badges actually do affect online behavior. It's sort of just been kind of an assumption of the designers of these sites that badges actually do anything to people's behavior. And if so, how can we model them? And then how can we actually use those models to influence the design of these systems?
Sorry, how do you get a badge? Does it depend on the score of your answers or something?
Yeah, so and some of the badges that we've studied the most are really simple badges. So you need people to vote on questions and answers. So on Stack Overflow, they reward you just for the pure number of votes. So if you vote on more questions, you get a badge. If you vote on more answers, you get a badge. Because they want to incentivize behaviors that are important to the operation of the site, but where people might not naturally engage in those behaviors.
Would it make you more egocentric?
Possibly. I think the whole question about, do we collect lots of things we can wear on our chest, right? It's sort of like the similar to the military or Boy Scout type badges. So there's a long history of whether those things are good or bad for society, but it's a similar set of questions here. Yeah.
So do you get if you get more badges, would you get
that it accelerates as you get closer to the badge boundary, which was not completely that's not completely hardwired into the nature of the underlying model. But in fact, when we look at what happens in these sites like Stack Overflow, there's a huge acceleration up to this. So this is an electorate badge. You get 600, once you've voted 600 questions up or down, right, to say this is a good question, a bad question, you get this electorate badge. So this shows on, this is again lined up by when people win the badge. So this is actions before winning the badge, actions after winning the badge. Since people have to have at least 600 actions to win this badge, we have a long history going backwards. And notice that there's not a lot of stickiness to this. And I think this is one of the interesting things about these badges, that site designers often haven't had tools to think about either from a modeling perspective or even just from a sort of studying their own data perspective of, if you really incentivize people to do stuff a lot, both what else does it detract from, but also, and I don't know how, but notice the activity level back here, way before the badge, and the baseline activity way after the badge. It may actually be that this is depressing activity level for a really long time period. So, and these are things that are modeled, also predicts, although it predicts recovery back to the baseline rather than, but it, similarly, it predicts that, that this accelerated activity just falls off a cliff, which again you know, I think intuitively at the beginning, you would say this can't pop, people don't really change their behavior that fast. Oh yeah, they do. It just completely falls off a cliff. And so then this is just some other such badges. So with that, I'm gonna stop and turn it to more general questions.